Phase diagram is used to summarize the condition at which a substance exists as a solid, liquid, or gas. Or we use phase diagram to understand in what state water exists in certain condition. The condition here means with different pressure and temperature. From the phase diagram of water, we can see there is a phase boundary line here. I name it as O, A, D, and C point. For the OA point or OA line, it is sublimation curve. For the AD line, it is melting point curve or fusion curve, and between AC line, it is water vapor curve. There are three regions in the phase diagram of water: solid, liquid, and vapor. Let's take example of liquid region. At any pressure and temperature within this liquid region, the most stable phase is liquid. Same goes to the vapor pressure. At any pressure and temperature within this region, the most stable phase is vapor, and same goes to solid region. The point A is a triple point. For the triple point of water system is below 1 atm, which is at 0.01 degrees Celsius, and 0.006 atm is the only condition under all three phases can be equilibrium with one another. Let's take a look at the AD boundary line. Okay, if the pressure increase above 1 atm, it will increase the boiling point and lower the melting point here. Okay, a decrease in pressure will lower the boiling point and raise the melting point. So this is boiling point, which is at 100 degrees Celsius, and this is melting point, which is at 0 degrees Celsius. In water phase diagram are same as carbon dioxide phase diagram, but it's only different at the AD boundary line. For water slopes to the left or has a negative slope. For phase diagram of water, the AD point has a negative slope, but for phase diagram of carbon dioxide, the AD line will be positive slope. From the phase diagram of water, we can see here the normal melting point of water is 0 degree Celsius, and the normal boiling point of water is 100 degrees Celsius. If the pressure above 1 atm, okay, it will increase the boiling point of the water, and it will lower the melting point of the water. So meaning that the value of melting point of water is less than 0 degrees Celsius, and the value for the boiling point of water will be more than 100 degrees Celsius. If the pressure is lower than 1 atm, it will lower the boiling point. Okay, for example, it will lower the boiling point of the water, which is less than 100 degrees Celsius, and increase the value of melting point, which is more than 0 degrees Celsius. Okay, so make sure you understand how to read the phase diagram of water. The concept is the same with the phase diagram of carbon dioxide. In the phase diagram of carbon dioxide, it is almost similar with phase diagram of water, but as I said, the slope of the curve between the solid and liquid region is positive slope. This positive slope is due to melting point or freezing point increase with increase in pressure. The triple point here, which is at 5.11 atm, means that carbon dioxide cannot exist as liquid below this pressure. Okay, so this is liquid. Increase the pressure, the carbon dioxide can exist as a liquid. The entire liquid phase lies well above 5.11 atm, or we can say 5.2 atm pressure. So the solid carbon dioxide can't melt at 1 atm. Okay, melt meaning that from solid become liquid. When solid carbon dioxide is heated at negative 78 degrees Celsius at 1 atm, the carbon dioxide solid sublimes. Sublimes meaning that from solid to gas. Solid carbon dioxide called dry ice because it looks like ice and doesn't melt. I would like to refer on the XD curve, which is solid liquid equilibrium. So this is XD curve. This XD curve indicates to melting and freezing point curve. So the density of solid carbon dioxide is greater than its liquid. Solid liquid equilibrium has a positive slope, meaning that it has high melting point, and as the pressure increase. The equilibrium exists at pressure 5.11 atm, which is above atm pressure, and it is impossible to melt at 1 atm for all temperature. For the XZ curve, which is liquid vapor equilibrium, so here is the vapor pressure and boiling point curve. So as the external pressure increase, the boiling point will increase. The boiling point of the liquid carbon dioxide increase until it reach the critical point at 72.8 atm and 31.1 degrees Celsius. At this critical point, phase boundary between liquid and gas diminish. Liquid carbon dioxide boil at room temperature when pressure at 67 atm. Okay, here. For the XY curve, which is solid gas equilibrium, this is a vapor pressure of solid carbon dioxide. When the vapor pressure increase, the temperature will increase. Below the triple point, the solid carbon dioxide sublimes to vapor, which is from solid to gas. At room temperature, which is at 25 degrees Celsius and 1 atm, okay, the solid carbon dioxide, which is known as a dry ice, sublimes to carbon dioxide gas. So from solid carbon dioxide now become carbon dioxide gas. The crystal of carbon dioxide obtained at 1 atm when it is cooled at negative 78.5 degrees Celsius, and the triple point here reached at 5.11 atm and negative 56.4 degrees Celsius. In order to answer this kind of question, you should be able to label all the components and with the correct axis. So this is the graph of pressure versus temperature. The X will be solid region, liquid region, and gas region. So B is the triple point where solid, liquid, and gas are at equilibrium. So from solid to liquid, it involves melting process. And how to calculate the degree of freedom along the BD line? So using the formula F equals to C minus P plus 2. So as this is involve only one component, which is carbon dioxide, so 1 minus 2 for the phase as it involves liquid and gas. So the answer will be 1.